So that's done. Okay. I think we're ready to go. Just a couple of things. I want to get my camera ready. Okay. Okay. So just a couple of announcements. Remember, there's a WebAssign due on Sunday. And also, if you have questions about the WebAssigns, you can send me the Ask the Teacher questions, or we can meet. We can always share screens if that's helpful to you. And I should have, I anticipate again leaving class early today before 2:10, and so there's time after class we can talk as well. And then for the exam, it's going to be, the day isn't set, but it's the week after next. And so, just be prepared for that. I'll have better announcements, next week about what it's going to cover and all that kind of thing. And I'll give you like an outline of what you need to do, what you need to prepare, what's going to be on it, and everything. And like I say, just it'll be probably it'll be the week after next. I'm not sure exactly whether we're going to do it in class or have it. You can do it on your own time. I haven't quite figured out the format yet since this is new, but just wanted to alert you to that. Okay, and the next week we should be getting into chapter 2. So, any questions before I start? Okay, I'm going to just kind of review what we're going to talk about today briefly, maybe take 5 minutes or so to do that and see if there's math questions. And one of the things I was going to talk about is composition of functions and how to find inverses and things like that. So I'll get to that in a second. I did remember, if there's any, I think I have all the projects except for maybe one, but definitely be in touch if you didn't submit a project. I'm going to grade those this weekend. And I will have the feedback form once I have all the projects out. I mean, once I have all the projects collected, I will send out the feedback form where you can talk about, it's just a peer feedback, and I'll just leave it at that. Okay, so questions then. I have one question in the private chat about compositions. Okay, which I'll get to in a second. Any questions otherwise? In the meantime, if you want, you can download handout number 8, and I'm going to just sort of review the topics that are on that, so to see if there's questions. Okay, and I'll start with composition. So I'm just going to do an example. So here, I'll just do something like this. Okay, so we have a function, and the way that I think of this is that the X is really a slot that you put stuff in. So whatever goes here also goes here and here. And that might require you to do a little bit of extra work, like simplifying if this phrase is anything more complicated than an X. And you can put anything you want here. I mean, it's silly, but something like this actually makes mathematical sense, if not real life sense. So sort of opening up that question about whether math is real or not. So anything you put there works. And so that's the function I'm going to talk about. And let's say my g of x is 2x minus 1. And I want to look at f of g of x. And so again, what I'm thinking about is that f looks like this with the empty slots. Sorry, that should be a cube. Minus 2x, sorry, that should be an empty slot too, plus 3. So whatever I put here goes here and here. So g of x, I say, oh, well, that's 2x plus 1. So that's what I'm going to plug in. And so that's going to go here and here. Okay. So then, okay, well, now I'd want to simplify. And this is a cube. And this is something I probably wouldn't give you to do, right off the cuff. But I'm going to, let's say I look up to see what that is. And that turns out to be 8x cubed plus 6x. Sorry, there's a formula for this, and I have to do it in my head. 12x and then it's going to be 6x plus 1. And then here, minus 2x plus 1. So whatever this does, I have to do that to simplify it. And then I would distribute the numbers. So distribute the 3 to everything here. So 24x cubed, 36x squared, I forgot the square there, 18x plus 3. Now I do this one, minus 4x minus 2 plus 3. And then I just have to gather like terms and simplify. So I'd say, okay, well, there's only one cube term. There's only one square term. But I notice that I have a couple of x terms. So 18x minus 4x. And then I have 3 constant terms here. 3 minus 2 plus 3. And so then what I would have to do is just simplify everything else. 14x, 3 minus 2 is 1 plus 3 is 4. So that would be, this is what f of g of x is equal to. And I did kind of a complicated example just to sort of illustrate things. But again, the key idea is that these x's are really blank spots, blanks to fill in, and whatever goes between the parentheses gets put here, no matter what it is. You know, you just put it in there and then you simplify it. So I had a question about that earlier. It was a private message. If you want to, I hope this helped. The person that asked. If not, I can go into more detail, or we can talk about it in more detail later. But any questions about composition? Okay. Okay, so the ones you have in the worksheet are easier. I just kind of, like I say, I wanted to do one that was a little bit complicated. Okay, so I'll give you a few seconds to ask any questions. And then I want to talk a little bit about inverses and finding inverses. Again, I talked about this in the video, but I think it's good to go over in class briefly. Okay. So the next thing I'm going to talk about is inverse finding. So I'll do an example of an inverse. And I'm going to look at just a linear function because it's nice and simple. So what you do here now, I'm going to go over what this operation is. This tells me to take x, multiply x times 3, and add 2, and that gives me whatever my y is. So for example, if I had f of 3, I would have 3 times 3, this 3 here, plus 2, so I would have 8. That would be my y. Okay. So the question is, I want to undo this. And there's a couple of ways to do it. And I want to just, I did these in the video, but I think it's good to go over to refresh people's memory. And the way to do it is to do it, the book has you do it, in the video I've kind of followed that, is to have you do it verbally, sort of as an, so you understand what it does. So here, I take 3, I take x, multiply it by 3, and add 2. How do I undo that? And that's what the inverse is. This is kind of like wrapping a present up, and the inverse is unwrapping it. So what do I do? And you can do this on the chat. Yeah, thank you. Glad people are paying attention. Okay, so somebody pointed out that was not 11. So how do I undo that? If I start with this 11, how do I get back my 3? And you can do this on chat, or you can kind of do it on your own, or you can speak it out. So I want to undo that. And let's go through the steps. I have 11. What do I have to do to undo it to get back to 3? And these are the operations that I do. So if I start with that 11, what's the first thing I do? Again, I want to do the opposite of what's circled,
Subtract 2.
Yep, and that's going to give me 9. So I subtract 2. And then what do I do?
Divide by 3 after that?
And then I divide by 3. So I subtract that and I divide by 3. Okay. And again, that undoes this. So you have to do things kind of, you're going backwards to get back to where you start. Rather than adding 2, I subtract 2. Rather than multiplying by 3, I add 3. Okay. So can you find, remember this is the symbol for the inverse. And X is kind of the way we always write what's called the dependent variable. So even though kind of it's really a Y, but for mathematicians, you usually put an X there. So what's my formula for this? Subtracting 2 and then dividing by 3. If I want to have an actual formula with an X in it. So I want to turn that into a formula. So what do I subtract 2 from?
X over 3.
Okay, so I'm listening. You tell me what you got. You said X over 3.
Or is it, and then X, or then minus 2.
Okay, so let's try that out. If we put in an 11 here, we should get back 3 if we undid it, right? Because 3, that's part of the function, the 0.311. So we're going to have 11(3) on the inverse. So does that work? If we plug in 11 here, do we get back the 3? Let's see. You get 11 over 3 minus 2. That's going to be 11 over 3 minus 6/3. That's 5/3. So that doesn't give us back 2. So that's close, but not quite correct. So you always start with an X. And what's the first thing I do in the inverse? Subtract 2. Yeah. And then I divide the whole thing by 3. And let's see if that works. So again, we'll plug in 11, because 3 gave us 11. 11 should give us 3. 11 minus 2 over 3, 9 over 3, 3. That works. Okay. So one of the things with an inverse is you've got to figure out how to undo what you do. That's kind of what an inverse does. And the way that the book and the videos, and again, following that, one way to do that is just to it's just literally undo it step by step. Okay. Now, is this a function, that formula? Is the inverse a function? But
yes.
Yeah, it's a linear function. Anytime we get something that is of this form, I could divide this by 3. And this is of the form mx plus b. As long as this is always going to be a function. Okay, so that's one way you know it's a function. Now, if it's, you can also draw this. This is the line, the inverse is the line x minus 3, y-intercept 2. So it's going to go through here. Again, this is just a rough sketch. It's going to go through minus 2/3, because that was the formula. And then it's going to have a positive slope of 1/3, so not very steep. So something like that. And again, if you look at that graph, that's a graph of a function. So this is the graph of f inverse, and that's x over 3 minus 2/3. So that's a function. Okay, so the kind of questions I might ask are like, is the inverse a function? Why or why not? You answer, why is this a function? 1 is the graph passes the vertical line test, graph of f inverse. And 2, y equal mx plus b is always a function. You plug in X, multiply it number and add B. There's only one possible answer. Okay. Okay. So again, those are the kinds of things that we'll look at today. And I wanted to do one more technique. I'm going to use the same example. So we're starting off with f of x equal 3x plus 2. And this is a way to do this algebraically. You can always do this the way we just did it. But another way to do this that I mentioned in the videos, you set y equal 3x plus 2, and you solve for x. And then you're going to switch x and y at the end. So I solve for x here. I subtract 2 from each side. And then I divide by 3. But we live in an x world, meaning x is always going to be the independent variable, the thing that varies. So the way that you write this as a function, you would switch x and y. So you would have x minus 2 over 3 equaling y. And that would be what how you'd write f inverse. So we generally write functions in terms of x or some variable t. So that's why I'm switching x and y. Okay, so that's another way that you can find it using algebra. And it's up to you which way that you want to use. I just wanted to point that out. Okay, I think we're ready to go. I'll form groups in a second, but any questions? Okay, I'm going to form you into groups, and then remember you want handout number 8, and then I'll see you in the groups. Okay, I'm going to open up the rooms. Hi, Isabella. I'm wondering if you're here. It looks like you haven't joined the room, and I'm wondering if maybe you have connection issues or not.
Sorry, my computer froze.
Oh,
For a second, I'll join now.
okay, that happens. I know people sometimes just get kicked off, and so they're not able to join. So, okay, I'm glad it's working. Hi, Matthew. I moved you around just to even up the groups.
Okay, I was a little confused.
I just wanted to let you know that's what I was doing. So, yeah.
Okay,
Because your group had 5, and this one only had, since Ahmed, it only has 2 people. So,
okay.
okay, good. Okay. Okay, so well, while I'm here, any questions about anything?
Before you go, I'm actually gonna go in like a few minutes, so it'll be like 2 people. I don't know if you wanna like rearrange it again.
Yeah, I was thinking of maybe moving. No, I think I'll get somebody else and move them into here, so you'll have 3 people when you go, Sydney.
Okay.
Okay. Okay, so I'm not hearing any questions. I'll probably just because I just dropped in at the beginning, so I'll let you look at it and then I'll be back.
Okay.
Sounds good.
Okay. Hey, David. David, I'm gonna put you in a group. We're already in groups.
Hey, yeah, sorry about that. My computer was having problems.
No problem. If that happens and you can't get in at all, just let me know. That
Okay.
happens a lot. So anyway, I'm gonna move you into the second group.
No problem.
Okay.
Are we doing the handout?
Yeah, and the handout's number 8.
Yeah, okay, cool.
Okay, good. Okay, bye-bye. Hello, everybody. Just coming in to say hello, and I stole one of your group members because the other group only had 2 people.
Sounds good.
Okay, so questions on anything?
Not yet, I don't think.
Okay. Okay, see you in a bit.
Okay, so 4x squared plus 2x plus 2x. Yes.
Okay, so, and then we can like combine the stuff. So it could be 4x squared plus 4x plus 2.
It'd be plus 1 because we'd have to multiply what's in the parentheses by
Oh,
the 3
right.
first.
So,
Start out 12x squared plus 12x plus 3 plus 1. And then 12x squared plus 12x plus 4.
sorry. I need to add this. I'm so sorry. I don't know how to like decline my call.
That happens. It's happened to me.
Yeah.
Okay. So I'm just, it seems like you're going, that you're having a good discussion. So I'm just checking in to see if you have any questions or anything.
Yeah, I'm just still confused on this section. I'm not gonna lie.
Okay.
Like, I just don't understand like this stuff. Like how to get, like I kind of get it, but not really.
Okay. Do you see where we got it looks like you got it right.
Yeah, because Katie was helping me, and I tried to understand where, like, I'm just confused, like, on why we have. I don't know why this person. I can't talk right now. So sorry. Hold on. I'm just gonna put my phone on my computer on do not disturb.
Okay. So, yeah, if you could tell me, like, so let's look at A. Let's give us something to look at, right?
Yeah.
So so that tells you you're going to plug in g of x for every x that's in F.
Yeah.
So you would, whatever that x is, so it would be something like, I don't know if I can, let's see if I can write on this.
If you share your screen, I think you can write on it.
Okay. I can annotate here and then erase it. Is that okay?
Yeah.
Okay.
Oh, wait. Oh, that's so cool.
Oh, I didn't even know you could do that.
Okay,
Me
good.
either.
So that's what we want, right? Oops. You
Yeah.
can erase me too, so we can have like a dueling annotations. Okay. So I wish I didn't have my name there because I don't know if you see that, but it's really annoying to me. So basically this is F, I identify what F is, and I'm not going to put the variable in. Okay, and that parenthesis stands for that x, okay? So then whatever is between these parentheses here has to go right here.
So, okay. So why is it squared though? Is it
Oh, because-
always
Because I look at f and it says 3x squared plus 1.
okay?
So no matter what, it's like I don't know. Do you ever watch the Three Stooges? You ever seen them?
It's been a while.
They're really stupid, but they're they're kind of like, they're not refined people, and they go to some party, and then they're told to just look at the hostess and whatever she does, like do it. Okay.
Okay.
And so they like, she gets a bee down her dress and starts moving all around, and they start doing it, and and so that's what a function is. That stupid. It's just whatever it's telling you to do, it just does it. And so here it says, okay, I've got to plug in g of x, I guess, and so you just plug that in for each.
So 2x plus 1 would be plugged in there.
Exactly, right.
Okay.
And then you have to do it, the function f, and then f tells you, okay, I take that 2x plus 1 and I square it.
So 2x plus 1 squared is 4x?
No, because you got to, when you FOIL it out, it's really 2x plus 1 times 2x plus 1.
Okay. And then the plus 1 on the outside?
I'm sorry? Oh, yeah.
And then,
Oh, yeah, I put a 4 there. I don't know why I did that. That should be a 1. I just miscopied. Okay. So then I have to FOIL that. I do 4.
So,
Oh, go ahead.
oh no, you're good. 4x plus 2 plus 1?
Close. It's 2x times 2x. That's the first thing you do. That's 4x squared.
Oh, 4x squared, okay.
And then you multiply this 2x times 1 and this 2x times 1.
So, and then 4x squared plus 2x plus 1 plus 2x plus 1.
Yes. Well, just plus 2x. We got 4x squared plus 2x plus 2x. And then the last thing you do is multiply this 1 times that 1. So it's just a single 1.
Okay.
And then all that would go here.
Okay, and so our final answer is, then we still have to multiply out?
Yeah, you have to multiply everything by the 3.
So 12x squared plus 6x plus 6x plus 3?
Yeah, but it's 3 times, let's see, 3 times, it's going to be 3 times 1, so that's going to give you 3. Right, exactly. And you can combine those x's into 6x plus 6x is 12x.
Okay.
Right.
Okay, and then I have a quick question about the end of the question. So one of my last steps was like 12x squared plus 12x plus 4. Do you want us to simplify it to the point where like we take out all the 4s? So it would be y equals 4 in parentheses 3x squared plus 3x plus 1.
So yeah, so yeah, what you want to do is you want to simplify everything. So say that again, what you have for your final, and this is for g of x or g of f or f of g?
The letter A. So the one you're still working on.
Right, yeah.
So I got 4, or y equals 4, and then in parentheses 3x squared plus 3x plus 1.
Okay, I would do it, here, let's just do it all out, okay?
Okay.
Okay. So you see where I'm getting everything in the parentheses?
Yeah.
Okay, so 3 times 4 is going to give me 12x, sorry. I should make that a 12. 12x squared. And then 3 times that 4x.
How come it's still squared though? I'm just a little confused.
Oh,
by
the
that.
x, because we got these 2 x's here, 2x times 2x.
Okay.
That gives us 4x squared, because it's this.
Yeah.
These are supposed to be x's.
That was it before like we multiplied it by 3.
Yes, exactly. Right.
Yeah.
And so once you have the square, it stays. Okay. Okay. And then so you get 12x squared, and then 3 times 4 is 12x. And then 3 times 1 is plus 3. And then you have this one here still.
Okay.
And then what you would do is you would gather any like terms. Okay.
So 12x squared plus 12x plus 4.
Exactly, right. That's the simplified answer. So that would be the answer to this right here.
So f of g of x equals 12x squared plus 12x plus 4.
Yeah.
So you don't want us to simplify it further past the 12x squared plus 12x plus 4?
Well, you do, yeah, that's how you want to write the answer. The final answer would be plus 4.
Okay,
And you don't have to factor the 4 out. Is that what you were asking before?
I think so.
Yeah, that's perfectly simplified. I mean, you can factor out the 4, but I don't think it really gets it. You know, I don't think you gain anything from it. It doesn't make it any simpler to work with.
Okay.
Okay, that makes sense?
Yes.
Yeah.
Cool.
Okay. So I had a question from another group, so I'm going to go there and then I can always come back with more questions. But does that help?
Yeah.
Okay, good. Okay. I'll see you in a bit.
Thank you.
You're welcome. Oops, I can't get out of here. I can't see the leave. I'm trapped. Sorry. It's really not showing up for some reason. That's so strange. Never seen that before. So do you mind unsharing and then sharing again? That maybe that's why I'm not seeing it.
Seeing what?
Oh, I'm not seeing oh, there it is, finally. I didn't get the option to leave the room. I couldn't find it. It wasn't on my screen.
Oh.
Okay, but now it is. Okay, I'll see you. Bye-bye.
Bye.
Hi, I saw that there was a question.
We were just a little confused on how to find the domain and range for the two in number 3.
Okay, so do you want to share for that?
Oh,
Jeff?
sorry, I have it up on my
Ah.
computer and I'm on my laptop, so I
Okay.
can't share the
Okay,
thing.
okay.
It's the one where it just gives you the string of.
I'll share. Let me open it up and then I'll share mine. I think it's just easier if we have something to look at.
Okay.
Okay, there we are. I'll be with you in a second with the share.
Is it limited to just the points it gives, or are we supposed to have?
Oh yeah. Okay, it's limited. Yeah. So it's like if you look at the function. Oh, I wanted to annotate. Like, there's I do have some options somewhere to annotate. So if I just circle this number here, all the first coordinates, so the domain is just going to be the domain of f, not the inverse, but of f. It's just going to be all the first coordinates.
Oh, so it's limited to just the.
Yeah, because you're giving the actual. Here you're specifying what the function is, just these 4 points. So the domain would be all the first points. So 1, 2, 4, and 5. And then the range would be all the second points. Okay.
Okay.
Yeah.
I think we were overcomplicating it by trying to.
I'm good at that myself. So I totally get that. Okay. Okay.
Can you explain how to do A?
Sure. Yeah. So basically the inverse is you just reverse everything. So a function is a set of points, a set of pairs. And so the inverse is just going to be, I forgot the of x there. It's going to be 3, 1 instead of 1, 3.
Oh, okay.
Because the idea is, and then you do that for all the other ones. And the way that we look at this tells us that f of 1 is 3. That's how you interpret it. And then f of the inverse, of the inverse just undoes it. So it reverses things. F of 3 is 1.
Oh, okay.
Okay. So that's what that tells us. Okay. Now, if we had another one that was like, let's say, if we go over here, we know that f of 2 is 3. So that tells us that f inverse of 3 is what?
2.
Right, but what did we just say before f inverse of 3 was?
Oh, it's 1.
So what happens when your first coordinate goes to 2 second coordinates?
Not a function.
Exactly.
Yeah.
So that's the answer. That's how you address that. You kind of say, oh, okay, that's not going to work. Okay, it still has a domain. It's a relation now. It's not a function. It's still a relation, but it's not a function. And that's because, and that's precisely because if I say undo 3, you say, well, what do you mean undo it? It could be 2, it could be 1. Which one do you want? And by undo, I mean, however you get to 3, go backwards. So kind of like it's like this. This is what f does. And that's fine. I'm sorry. Oops. And then we have, and then we also have 2 goes to 3. That's what f does. So what the inverse does now is going to go backwards, right? And it does 2 things. That's what the inverse does.
Okay.
Right.
So then it's not a function.
So it's not a function, just like from what we learned earlier. Yeah. Okay. Okay. Does that help?
Yeah, it does. Thank you.
Okay. Good. You're welcome. Okay. So I have a question from another room, but if you have another question, I can answer. Otherwise, I'll go back and see that.
Sounds good.
Okay. And I think I have to, well, I'll stop the share too.
Okay.
Okay. Yeah. I think it'll take off when I leave anyway. Okay. See you in a bit if you have questions.
All right. Bye.
Hi. I saw that there was a question, so.
Yeah, Dr. Alexander, I had a question about 4.
Yeah.
So,
Do you want me to share it? That'd probably be easier if I
okay, just wasn't sure. It said to like take the inverse of it, so I wasn't sure if you're supposed to subtract 1 and take the square root, but I wasn't sure if the -1 is supposed to be in the root or outside the quantity.
Okay, when you take a square root, remember, you have to you do it in the midst of a problem like you have to here. You have to take both square roots.
For 4?
Yeah.
So like I had the square root of x minus 1, or would it just be the square root of the quantity x and then -1 on the outside?
Okay, so
how would that look?
Let's see. Okay, so if this is going to be equal to y, right, then we want to undo it. And so we have to subtract 1.
Okay.
Then take the square root.
Okay. All right.
Sorry, I didn't do that right. Let me do that a little bit more carefully. So again, when we undo it, you start with your x, because that's what you're starting with. You're undoing it. Even though it's a y, you have to subtract 1, and then you have to take the square root.
Okay. All right. Yeah. See, I just wasn't sure if that -1 was supposed to be on the outside. That's all I was confused about.
Yeah. That makes sense?
Okay.
Yeah.
Yes. Yeah. Thank you.
And that's key too, that you have to have the plus or minus there because yeah, you don't know which one, that should be a clue to whether it's a function or not.
Okay. Awesome. Yeah. Thank you.
I have a quick question about this one. So for A and B, what exactly do you want from us? Like I found, like I did that, like plus or minus, but I don't know.
Okay,
for
yeah.
A or B, I don't.
Yeah, so again, so let's say I'm answering this to hand in. So I would say, okay, A, I subtract 1, right?
Oh, okay, so use words.
Yeah, I mean, you don't have to. Yeah, I mean, but yeah. So you could do it two ways. So you subtract 1 and then take square root.
Mhm.
And rather than use the word, I'm going to do that. Or you could just say, starting with x, I subtract 1, and then I take the square root. And that leads, so you're kind of answering both at once.
Okay.
So that would not be a function, right? Because it's plus minus.
I forgot the plus or minus. Exactly right.
Okay, awesome.
Like if I plug in 17, I'm just making that number up. Then I would get x is equal to plus or minus square root of 16. It's supposed to be an equal here that I forgot, which is plus or minus 4. And just to look at the function for a second, if we plug 4 into the function, it goes to 17, right? We plug that into f.
Right.
And then if we plug minus 4 into f, it also goes to 17. But if we go backwards now, the inverse, well, now you're in inverse land and you say, where do I take 17? What's your answer? 4 or minus
negative 4.
Right.
Would it be 16? Oh, plus 1. I forgot. Never mind.
Yeah. And so it can't be a function because it's mapping. 17 doesn't have a single answer. When I say, how do I undo 17? There's 2 ways to undo it. So the inverse isn't a function.
Okay, but the f of x is a function.
Yeah. Yeah, because if you look at f, anytime we just have squares or cubes or just you're doing something to x, there's only one way to do it. When you undo it, there could be more than one way.
Okay.
Okay. So f is a function, but the inverse isn't.
Thank you.
Okay. Okay, other questions? Are you good?
I think I'm good.
Okay.
Yeah, that about covered mine.
Okay, good.
Thank you.
You're welcome.
Howdy.
Hey, oh, Sam, there you are. Yeah. What's up?
I got kicked out of the breakout rooms.
Oh.
And you have to assign me to them.
Oh, was that number 7 you were in?
Yeah, I believe I was in number 7.
Looks like somebody else got kicked out too, because there were 3 people in there.
Well, that's weird.
Yeah, that was only 1, so yeah, I can't remember. So right now Elizabeth and Isabella are in it. Who else was in there? You remember?
No, I do not.
Not a problem.
They
Okay.
weren't talking, so I didn't really.
Okay. So do you just want to go there or do you want to go somewhere else?
It doesn't matter. I can change between groups once I'm in.
Okay, good. Okay, I'll put you back there.
Okay, thank you.
Okay, take care. Uh-oh, you're not going back there. Oh, there you go. Hey, everybody, I'm just kind of checking in to see how you're doing, where you are in the process, see if you have any questions.
I'm good for now.
Okay.
Yeah, I'm on number 5.
Okay.
Yeah, same.
Okay.
I'm doing okay, thank you.
Okay. How about you, Susie? Doing okay? Any questions?
Yeah, I'm on 5B.
Uh-huh.
Can you help me with that one?
Sure. I'm gonna share the screen. Here it is. And that way we can, that just makes it easier, I think. Okay. Okay, so this one right here, right?
Yeah.
Okay. And where are you stuck?
Is that one just trying to find the X value then? Or at least
Yeah.
how do you start it?
Okay. Oh, let me annotate this. Okay. So I would say you're doing A, right? So to me, it helps sometimes to see what F does. So I'm just going to take a random number, a small number, 2, and I'm going to compute that. And that's going to be 2 cubed minus 4. And so that's going to give me 4. And so that means that f of 2 is 4, okay?
Mm-hmm.
So the inverse, whether or not it's a function, it's going to take 4 and hopefully give me back 2. And if it gives me back more than one number, then I know it's not a function. So that's what has to happen. So, okay. So I say, okay, so for the inverse, I start with my number, which is going to be 4. And then to get to 4, I had to subtract 4, right? I'm sorry, there's too many 4s here. That's confusing. But to go backwards, rather than subtract 4, I have to add 4. Does that make sense?
Yeah.
Okay. Because that's the last thing I did. And then I have to take the cube root. So you just write it like that. And then what's the cube root of 8?
2.
2, right. So that works, right?
Yeah.
Okay, so again, I started with x, and what's the first thing I did? Again, this is for the inverse.
Oh, the inverse?
Yeah.
Oh, so plus 4?
Exactly. And then what?
Then the cubed?
Well, cube root.
Yeah.
Yeah, because that's the opposite of a cube, is taking the cube root. Okay. So that would be the formula. And notice I start with whatever I start with, I add 4 and then take the cube root. And so that would be f inverse. Does that make sense?
Yeah.
Okay. Now, when you take a cube root, there's only one cube root because, square root, there's 2 because negative times negative is positive. So a square root of 4 could be 2 or minus 2. When you take a cube root, that doesn't happen because if you have 3 minuses, you end up with a minus. And if you have 3 pluses, you end up with a plus. So you don't have that ambiguity that you have with the square root. So each square root only has one answer. I'm sorry,
Okay.
each cube root only has one answer. Each square root has 2.
Okay.
So that would mean that if I take any number and apply this formula, the inverse formula, I'm only going to get one answer. Does that help?
Yeah, thank you.
Okay, you're welcome. Okay, other questions? Okay, if you have other questions, let me know. I'm going to stop the share and then I'll see you in a bit.
Thank you.
You're welcome. Hey, Kai. Yeah, I don't know if are you able to hear me, Kai?
Say that again.
I was wondering if you were able to hear me.
I'm sorry, I didn't.
Yeah, did you just,
Yeah, I did, but say that again.
did you get kicked out of a group or did you, I didn't notice if you were here today or did you have problems getting in?
I have problems getting in today.
Okay, good. So we're doing handout number 8. And I thought I'd just put you in a group. Is that okay?
Yeah, that's fine.
Yeah. And then, but before I do, I mean, did you have any questions? We're doing composition of functions and inverses. And if you have any questions or if you want me to go over anything before I put you in a group, there's one that only has 2 people, so I'll put you in there. I can do that before you go in if you want.
You said we're going over inverses and functions?
Yes, that and composition too. And I started off.
Okay.
Oh, go ahead.
Oh, you're all right. You can go ahead. I'm sorry.
And I started off class with a couple of short examples, and I can do that if you would find it helpful. Or if you just want to go right into the group, I'll do that. I'll leave it up to you.
I can look at a couple examples just so I don't go in dry.
Yeah, okay. So are you able to see what I'm writing on the paper? You might have to pin. Okay. So here's an example. I'll make it simple. So we have 2x squared minus 1. And then gx is going to be 3x plus 2. Okay. And then the first thing I do is look at this. And what that tells me is I start with f. Like the way that I think of a function is I think of whatever I plug in here, I plug it into the function and square it. Like if I plug in a 4 here, I put in 4, I square 4, multiply by 2 and subtract 1. So if I plug something complicated into the function, I just do the same thing. So I'm looking at f of g of x. And so I look to see what g of x is. Okay, so that's going to be f of 3x plus 2. And anytime, if I lose it at any point, just let me know and I'll back up. So I'm going to plug this into here. And then I subtract 1. And then usually have to simplify this. So I'm going to FOIL this out. And if you want me to go over it in detail, I can. But I'm going to get 9x squared plus 12x plus 4 if I square this. And again, I can go over that if you want. And then I get minus 1. And then I have to distribute the 2. 2 times 12 is 24. 2 times 4 is 8, minus 1. And then I simplify by just, there's only one x squared term, only one x term. So I just add the 7 there. I mean, I add 8 minus 1 is 7. Okay. So that would be f of g of x. Does that make sense?
Yeah, completely understandable.
Okay, good. And then g of x would just be the opposite. So with g of x, I know that g of x is 3x plus 2. So whatever goes here goes here. So I would just plug in f into here and do the same kind of thing.
When you say backwards, what do you mean by that one? I'm sorry.
Oh, I'll go through. I think maybe I didn't mean to say this. So g of x, we want g of f of x. So the opposite, that's what I meant. It's not this one. It's not f of g, it's g of f. And so I looked
Okay,
at,
okay, I got you. So
yeah.
just the opposite of it. I understand.
Yeah. I said it in a confusing way. So whatever f is, I plug in here. And so f is 2x minus 1, 2x squared minus 1. So I plug that into there. And then I just multiply through. 3 times 2x squared,
Right.
6x squared minus 3 plus 2. And that's going to be minus 1. Okay.
Alrighty.
And then the other thing we did was inverses. And I can do a quick example if you'd like.
Yes, that's fine.
Okay. So that's my function. And to do an inverse, I think it's good to plug in a function and see what you get. Plug in a number, I mean. Oops. So if I plug in 3, I get 4 times 3 minus 2, which is 12 minus 2, which is 10. So my function takes 3 and turns it into 10. Now my inverse is going to take 10 and turn it into 3. That's what the inverse does. I have to go backwards. So I think of what I did to get to that 10. Well, I took whatever my x was, multiplied it times 4, and subtracted 2. So now I want to take that 10 and get back to 3. So I got to reverse my steps. So rather than, the last thing I did was subtract 2. So what do you think I do here?
I'm gonna add it.
Yeah.
Am I wrong?
And
Okay.
then
Gotcha.
Remember, I want to do the opposite here. So rather than multiply by 4, what do I do? I want to divide by 4, the opposite.
Okay.
And I get 12 over 4, which is 3. So here I took x, multiplied it by 4, subtracted 2. So for the inverse, I take my x, I add 2, and then I divide by 4. But I divide the whole thing by 4. So that would be the inverse of this. This undoes this, and if you want to test it, you plug in 10. Now I have to get back 3 because that's what I start. Does that make sense? I have to get a 3 back. So I plug in 10 into the inverse.
Yeah.
Yeah, and I get my 3. Okay. So those are the 2 main ideas.
Seems easy enough.
Yeah. Again, if you have questions, just let me know. Okay, so I'll put you in. Oh, wow, only one person.
Alrighty, thank you.
There's only one person now. Elizabeth Kirshner's in there, and then I'll put you in 7. I think someone else lost their place. It's been happening today. So I'll see you there. Okay. Hi, Elizabeth. Hi, Kai.
Hello.
Hey, Elizabeth, you've been losing people today. It looks like they've been getting kicked out.
Yeah, I'm in a different group now. I'm confused.
Well, you've been there. You're the one that hasn't moved.
Oh, I see.
I know that Sam said he got kicked out earlier, and then Isabella got kicked out. I can't remember who else was there.
Sammy.
Who? I'm sorry.
Yep, Sammy also
Oh,
did.
yeah, right. And it just must be connection issues because I know that's been happening every class.
Yeah.
And so.
Yeah, I hope I don't go out as well.
And then Kai couldn't get in, and so she just joined the class. She couldn't get in earlier, and so.
Okay.
So I said, since you didn't have anybody, I thought it'd be good to put you 2 together.
Yeah, sounds good.
And then she and I went over kind of what I did at the beginning of class. You know, went over an example of composition and finding the inverses. So.
Okay.
And where are you on the worksheet?
So we got to either the 3rd or the 4th one.
Mm-hmm.
And gosh, no, I can't find the handout. What's going on here? Anyways, but I was actually talking to Sammy about foiling because I feel like I completely forgot how to do that and everything. So I was honestly just kind of looking at that a little bit.
You want me to go over that?
I mean, it would be helpful.
Yeah, I'm happy to do that. Someone else had a question about foiling today either. And I mean, earlier today, and I know you haven't been in math for a while, and so you forget that stuff. And so I'm happy to help with stuff like that.
Okay.
Okay, so I'm just going to take an example. I'm just making it up. And usually it's going to be just, 2 things like this.
Mm-hmm.
2x plus 5, let's say. Okay. And really what this is you're multiplying x times 2x plus 5.
Okay.
And then you're multiplying minus 3 times 2x plus 5. And this isn't how I'm going to do it. I'm going to FOIL it. And then you have to add things. Okay. So a shortcut would be x times 2x. I'll put a 1 there. And that's doing this multiplication here. And then, so that would be 2x squared.
Mm-hmm.
And it doesn't matter how you do this. And then I'm going to do x times 5. So that would be 5x. And I'll do the same thing with the 3. I'll do minus 3 times 2x.
Okay.
And then minus 3 times 5. So this is going to be 3. And that's the 4. So you're always going to get 4 terms when you do that. And the 4th term is minus 3 times 5. So plus minus 3 times 5. Now you notice that's 1, that's 2, that's 3, and then that was 4.
Mm-hmm.
So basically I did the same thing, it's just a shortcut. And then you add everything together. So 2x squared. This is going to be minus 6x here. When I multiply minus 3 times 2. So I add that to 5x. And I get minus x.
Mm-hmm.
And then minus 3 times 15. Minus 3 times 5 is minus 15.
Okay.
Okay. And then okay. And there's a trick for squaring I can show you if you want.
Yeah, that would be good. Because I think that's where I got
Right.
confused.
So we'll do the same thing with a plus b. Okay, so the first one is a times a. The second one was b times a. How about the third one?
Third one would be b times. Oh, you just said b times a.
So this
B
is my,
B.
that's my third one. I'll just do that one. It doesn't have to be that one, but let's say it is. Okay.
Okay.
So that's going to be b times a. Or a times b, sorry. It's the same thing.
Mm-hmm.
And then what haven't I done yet?
B times b.
Right. And so we get a squared. Now this and this are the same. They're just different order.
Mm-hmm.
So that's going to be 2 of those. And then b squared.
Makes sense.
So if we had something like 3x plus 2 squared,
Mm-hmm.
that's my a, and that's my b. And the formula tells me, well, a squared, square the first, square the second, the last, and then you multiply them together and times 2. Okay, so that's going to give me, I'll go back to that. What did I use, pink? I think I used this color. So that would be a squared would be this squared.
Mm-hmm.
So 9x squared, or you can write it this way if you like, to start. And then you multiply these together and multiply that times 2. So it's 2 times 3x times 2. And then you square the last one. So you would end up being 9x squared plus,
I think where I'm getting confused is the 2 parentheses 3x times 2.
Okay, so when we look at the formula, it's just, notice it's this times 2.
Mm-hmm.
So 2 times AB. So my 3x is my A.
Yes.
So that would be my A right here. Oops, different color. And then 2 is my B. So the formula is 2 times A times B.
Okay. Okay. I got it.
I think I made it worse. I shouldn't have had a 2 here. I should have had a 5 or something. I think that's what confused things.
Okay.
Does that make sense now? Yeah.
Yes.
Yeah,
Yes.
And Kai, this is what I used earlier. I did a shortcut for, you probably saw that, but you probably saw that. Yeah. That's what I did earlier. Okay.
Okay. Thanks so much. This was really helpful.
Sure. Good. And then you said you're on number 5.
Yes. I don't understand where the handout is, but
You'll find it.
here we go. Here we go. Yeah.
I lose track of things in my, I have too many windows open and.
Me too.
Okay. Okay, doke. So I'll just let me know if you have any questions.
Okay. Thank you.
Okay. I'll see you, Kai. See you, Elizabeth. Yep. Okay. I'm going to undo the share so I can leave. Okay. Yep. Oh, Isabella. Hi. Sorry. I didn't realize you'd come back.
Yeah, I got my connection to come back.
Yeah, I wish. Yeah, it didn't. It should have pinged me. But anyway, you want me to put you back in group 7 with Elizabeth?
Sure.
Yeah. Okay. And then Kai Williams joined. She couldn't get in earlier, and so she just joined the class a few minutes ago. So she's there now.
Okay.
There's been connection issues today. So I know, and your group has been hard hit because Sam got kicked out, and you got kicked out, and I can't remember who the third person was. They got kicked out too. So.
Yeah.
Okay. So I'll move you back there.
Okay. Thank you.
You're welcome. Hi, everybody. I don't think I've checked in on you for a while, since the very, very beginning. So how are you all doing?
Pretty good so far. I'm done. I don't know about the rest of the group.
I'm also done.
Okay.
Yeah, so am I.
Okay.
It's bomb. What the fuck? What is this talking about?
Okay, so I'm probably going to bring people back in a couple of minutes to see where they are. So you all can relax for a while, and then I'll send out a message and when it's time to come back.
All right.
Okay.
Thank you.
Okay.
Okay.
I multiplied the 3 on the denominator by the 3 outside of the parentheses.
Okay.
Then I got 9 times x plus 9 minus 9. So I got 9x plus 81 minus 9. So I got 9x plus 72.
That sounds right.
Okay.
Wait. You used the 3 to make it a 9 from the denominator?
Yes, but I don't know if that was the right thing to do. I don't know.
I don't know. Would they cancel or would they make it?
Well, because you would have to multiply by the reciprocal, which would be 3.
Right. Okay. Okay. Yeah. No, that would make sense then.
Okay.
Are you doing
Sure.
number? Oh, sorry to interrupt. You were still talking. Yeah.
All right. We're actually just going on to the last question right now.
Okay, so you just did number 6.
Right.
Yeah.
It should be x plus 9 divided by 3.
Yes.
Good. Okay, excellent. Okay, good.
Okay.
Do you have a question though?
Okay, sure.
When it came to question number 5, it's root, correct?
I'm sorry, I didn't hear it. You cut out just for a second.
It's finding the cubed root, right?
Yes, exactly. Right.
Okay, cool.
And unlike a square root, there's only one cube root of a number.
Oh, okay.
So like the square root of 8 the square root of 4 could be 2 or minus 2.
Yeah.
The cube root of 8 is only 2.
Okay.
The cube root of -8 would be -2. So you don't have that. So it turns out the inverse would be a function.
Okay.
Okay.
That makes sense.
Okay. So I'm probably going to call people back in about 5 minutes or so, but I'll let you finish.
Thank you.
Okay.
Thank you.
Yep. Bye-bye.
For 7, I
I think I already checked in on you. You all are good, so I'll be back. Sorry, I meant to go to a different room. Just checking in to see how you all are doing.
Doing pretty good.
Okay. Are you still working or have you finished?
I'm still working. I think Matthew, did you have a question on number 4?
I had one on number 7.
Okay. I'll
Just
share.
about, the sine graph on. Oh yeah.
Okay.
I can pull it up on mine.
Yeah.
Oh, you have it. Okay.
Yeah. Oh no, I think I shared the wrong thing. Wait, what are you seeing? Are you seeing like a list of emails, or are you seeing the handout?
I'm seeing the handout.
Okay, good. It's not showing on my. Okay, here it is. Okay, good. Yeah, right. Okay, so that you don't need to know it's the sine, but yeah, it's the sine graph. Okay, yeah. I
just don't know if is it like a parabola where anything that would sort of disqualify it from being a function, is that just left off?
Because you remember the idea. Oh, go ahead.
Well, I just know when you invert a parabola, just all the negatives are just lopped off. It's not positive and negative square root. I didn't know if the same principle would apply to the sine graph, or
exactly
if it just would be a function.
Exactly the same. The other thing is too is if you draw a horizontal line, how many times does a horizontal line hit the graph? More than once. Right. So that makes it not a function, because that would mean that this x here and this x over here would have the same y coordinate.
Oh, okay.
And so if you said, well, if I go to this y coordinate right here, what's my x? Well, you could say, well, I just draw a horizontal line, and this hits the graph here. I go down here. Well, that x goes with it. This x goes with it. This x goes with it. So too many x's go with it.
Okay.
Yeah. Okay. And notice here that the horizontal line only hits the graph once there.
Yeah.
Okay. Okay. Okay.
So would I say the parabola also wouldn't be a function?
Right. Its inverse wouldn't be a function. Yeah.
Oh, I'm just looking at I was picturing like the numbers of what would represent a parabola, and then inverting that, because the square root of x.
Yeah.
Is still a function, but it's not. But it'd be the positive and negative square root. That it's,
because if I ask you the square root of 16, you say, well, what do you want, plus or minus 4?
Yeah.
So that's how it works with a parabola. There's a square in there. So when you take an inverse, you have to take a square root. And with a parabola, you get two numbers which go to the same y. And then, so that means when you say, well, what x's goes with that y? Well, you have two choices. But the way you were thinking about it was also, it was a different, I like the way you were thinking about it in terms of inverting it. Okay.
Okay, that answers my question.
Good. Okay. Okie doke. So is everybody pretty much done with it? Or I'm just trying to get a sense of where you are.
We were working at different paces and just checking in when we had questions for each other. So.
Yeah. I'm not done, but I think I'm going to continue to work on it like after.
Okay.
Yeah. Same. I'm not quite there yet either, but.
What I think I'm going to do is bring everybody back in a minute or two, and then I'll talk to the class. And then if people have questions you want to continue to work on it, I can stick around and help.
I definitely think I just need some more practice with this material.
Yeah. Okay.
Yeah.
Okay. Okay, doke. So I'll see you. I'm going to bring everybody back in a couple of minutes, and I'll see you in class.
Great.
Okay. Yeah. Bye-bye.
Bye.
Oh, Amanda, looks like you got kicked out.
Wait, I'm confused. Am I in the right room?
No, you got kicked. This has been happening all day. I mean, it's like several people just, like, they think they're in the room, then they're back in the main room, and so don't know what happened. And so, yeah. So but I'm going to call everybody back anyway. So you're back in the main room, and I'll just leave you here there. Sorry. How long have you been there? I didn't notice that you got kicked out.
Probably like a minute.
Okay.
Yeah, I left the main. I said like leave breakout room, so I clicked on that since you said you were.
I was gonna. Yeah, I got it. Yeah, that makes sense. Okay. So you didn't get kicked out. You just left on your own.
Yeah, I thought.
Yeah, yeah.
Because I thought doing it right then and there. So.
Okay. No worries. That's good. Okay. Okay. So I'm going to close all the rooms now, so people will be back in about 30 seconds, if not.
All right. Awesome.
Okay. Bye-bye.
Bye.
I'm just waiting for everybody to leave their rooms and come back. I think everybody's back. Okay. So it's about a little bit past quarter of, and so I wanted to bring everybody back. I'm wondering if there's any questions. Actually, first, before we go into questions, I noticed there was a lot of people getting kicked in and out of rooms today. So like there was some connection issues, and that's unfortunately just happens. And I apologize. Well, it's not my fault, obviously, but I wish it was more stable. I had a question. I'm curious. You can just send this on the chat. It's just how far people got. So I'll give you you can either send it to me privately or, okay. I'm just trying to get a sense. And if you see somebody from your group, maybe, that said you finished. Okay. Okay, so it looks like most people finished. So what I'm going to do is okay, good. Okay, so I had a question about B for 4, 5, and 6, and I'm going to answer that in a second. But if you finished and you feel like you're doing well and understand this stuff, you're free to go. Otherwise, I'll stick around. I'm going to answer that question about answer B for 4, 5, and 6, and then I'll talk to the whole class about that. And then I can also answer any individual questions or talk to people about questions they had, or talk to the groups. I mean, okay. So I need to go to see what the question B was. Sorry, I'm having a hard time. There it is. Okay, good. So I'm trying to, here we go. Okay, so here was the question that I had a question about. So I'm gonna send this out to everybody. Okay, so here's to everyone that's here. Okay, so here's the question. The idea let's see, question 4, 5, 6. Question B asked you to try to write out the inverse as a formula with x's. And the idea was to use your answer. And so I'm just going to use, does somebody want me to do a particular 1, 4, 5, or 6? I can do any of them.
I think either is fine.
Okay. So let's do 4. And again, I'm going to do this on the using the document camera. So if you have that one, you can pin that to the screen. And so 4 is x squared plus 1, that's f of x. And again, I'm just going to go do A as well, just so we can bring up to speed. So what I'm doing is I want to see what the function does. So I plug in a 2, and I get, okay, that's 2 squared plus 1. That's going to give me 5. And so the inverse is how to go from 2 to 5, how to get 2 back from 5. That's kind of what the question is. And so I have to reverse my steps. So notice that I went this way for f, so I have to go this way, but backwards to recover, to get 2 back. So I take my 5, and I added 1 to get 5, so I have to subtract 1. And then notice that I squared my x, so the opposite of squaring is square root. So I say, okay, if I do that, I get the square root of 4, and that gives me 2. So, well, we go so f took 2 to 5, and we figured out how to go backwards. Okay, now my formula, but then I made a mistake. Oh, sorry, you can't see all that. I kind of forgot something here when I took the square root. What happens when you take a square root in a problem? What do you have to do? You have to account for the fact that there's 2 square roots, because you're taking the square root, and someone's not asking you. So you do that here, and oh, really what I get is plus or minus 2. And that makes sense, because if I plug 2 in here, I get 5. But if I plug in minus 2, I also get 5. So really, when I do the inverse, I get plus or minus 2. I'm going to get plus or minus 2 back. So that means the inverse isn't a function. But so anyway, so okay, now I have to take a formula. So here, I'm going to have x stand for a random number, not just 5. I subtracted 1, and then I took a square root. But since I'm taking the square root, I have to do plus or minus. So that's the inverse. And so that's what I'm asking in part B. In part A, you walk through the steps of what it does to reverse it. And in part B, I'm saying, well, find a formula to fit that. Does that help? I can do another one too, if that would be helpful.
I have a question.
Sure.
So do you just put a random number in for x?
You mean right here?
Yeah.
What I'm doing is I'm trying to figure out what the function does, and I find it easier if I have something concrete. And so what I'm doing here, I'm just taking a random number to try to get a sense of what the function does. And then I can say, oh, okay, that's what I did to get to this 5. Now I know what I need to do to get back. So it's random in that sense, but I picked a number like 2 because it's easy to compute with. I didn't want to take a number like 51 because that would have been hard. Does that help?
Yeah, it does.
Yeah, okay, good. Okay. So for for whoever, you could answer me privately too, for the people that had that question, did that help, or do you want me to talk more about it? I'm happy to do either. I'm going to be an optimist and assume that helped, but if you want me to do more things like this, let me know. In other questions?
Can you talk about the domain and range?
Yeah.
Number 4?
Yeah, okay. So number 4, we have f of x is equal to x squared plus 1. Now, if I graph this, I know that I take x squared and then I just move it up 1, because the parent function is x squared. And so I look and I see that y equals 1 is the lowest y coordinate. And this graph just keeps going on to infinity. It just keeps rising, it never stops. So that means my range is going to be 1 to infinity. Okay. And then my domain for f, there's no restrictions on what I can plug in here. Remember, a restriction would be division by 0 or square root of a negative number or something. There's no restrictions. I can plug any x in there and it makes sense. So my domain would be all real numbers. So minus infinity to infinity. Okay. Now the inverse, we just saw that the inverse looks like this. Okay. Now remember, for the domain of the inverse, x minus 1 has to be 0 or above. And so, okay, I see a question which I'll come back to. So that means x has to be greater than 1 or equal to 1. And so that's going to be the numbers that I can plug into the inverse. So this is the domain for the inverse. Okay. Now notice I have a plus or minus square root. If I were to graph this, it would be the square root function and the negative square root function. And this graph keeps going on and on. So it goes up to infinity, but slowly, and goes down to minus infinity. So the range of the square root with the plus version is going to be 0 to infinity. With the minus version, it's going to be minus infinity to 0. So the range would be this. This is for f. This is for f inverse. Now, what do you notice about the ranges and domains? Like, what's the relationship between the range and the domain of f and the domain and range of f inverse?
It's flipped.
And that always happens. Because remember, the numbers that you plug into the inverse are the numbers you get when you plug something into the function, and that's the range of f. So that becomes the domain of the inverse. And then since the inverse gives you everything you put in back, the range is going to be of the inverse is going to be the same as the domain. And just sort of a trick, which maybe will help that make sense, and I hope this will show on the video. So that's the function for f, right? That's y equals f of x equal x squared plus 1. Everybody agree with that? Now, if you want to see the inverse, you flip the page over and rotate 90 degrees. Oops, backwards. Okay. So if you want to see the inverse, you rotate 90 degrees and flip the page over. Sorry. I had it right the first time. This is backwards for me. Can you see that, or is it too faint? It's probably too faint, but it's a trick to find the inverse. If I'm looking at the graph of the function and I want to see the inverse, I rotate it 90 degrees and flip it over, and then I see what the graph looks like. So that's a trick to kind of see it. Again, it may not be useful or not. Okay, faint, but it makes sense. Yeah, in class it works better because I can use, I didn't have a marker at hand to do that. Okay, so does that help with the domain and range?
Yeah, thank you.
Okay. Okay. And then the person that asked me about, let's see, they asked me about B. For B, what B says is try to use your answer to A to write out a formula with X's. So what I'm asking you there is, in B, is give me the formula for the inverse. And the way that I did that was that I looked at what the procedure was, and then I said, okay, what I started with was X, and then I did stuff with that, which I can go over more, but I'm going to wait to see if you have questions about that. Okay. Okay, other questions? And again, I'll get to the question about part B again. I just want to see if there's other questions first. Okay, So if the person wants to ask me about B that asked me the question, I think it would be, I may not be getting what you want. Oh, wait, okay. Okay, hopefully that helped. Okay, other questions? And again, if you want, if you want me to work on something with you, I'm happy to do that. Or if you just want to work, just kind of let me know what you want. And Trinity, I noticed that you got kicked out of your group earlier. I'm sorry, that happened to several people today. Okay, so there's still a couple of people here, and if you have questions, please let me know, and I'd be happy to answer them. And I don't know if there's connection issues and you're trying to leave and can't. Okay.
No, thank you.
Okay, sounds good. Hey, Vince.